Hello, I just wanted to make this short video to show you this book. It's called Differential Geometry. It was written by Louis Auslander. It's part of the Harper series in modern mathematics. It's a hardcover and it has a nice dust jacket on it. I'm just going to give it a whiff here. Smells amazing. And here it talks a little bit about the book. Let's take a look at this. It says, the treatment of classical differential geometry of surfaces combines both the modern and classical approaches to give the student a better insight into the subject. The first 3 chapters deal with the algebraic and analytic prerequisites for the rest of the book. Chapter 3 is unusual in that it treats matrix Lie groups rather than Lie groups. All right, let's go to the contents and take a look at what's in the book. Differential Geometry. Louis Auslander. And here's the copyright, 1967. That was a long time ago. And here are the contents. I'm just going to go through them so you can see. So differential geometry is not a course that is sometimes offered. Like, so if you're in college, it might be the case that your school does not offer differential geometry, or it's not offered often. So that's not uncommon. And that's it. And you do need to know some serious mathematics to approach this. I mean, let's just look how it starts. So this is algebraic preliminaries. Let's read this together. Inner product spaces. Let V be a finite dimensional real vector space. Okay, so you have to know what a vector space is, right? So right away. And let psi from V cross V into R, where R denotes the real field, be such that you have the following. So you have psi of a sub 1 x sub 1 plus a sub 2 x sub 2 comma y. Okay, so it distributes basically. It's like you have linearity. You have linearity in the first variable, and you have linearity in the second variable, where a sub 1, a sub 2 are in R, that's the real field, and x sub 1, okay, these are in our vector space. We will call psi a real bilinear form of V, which makes sense, right? Because it's linear in both variables, therefore it is bilinear, right? So that's why they choose that name. We will say that psi is a symmetric bilinear form if you have this property. That's pretty cool, symmetry. What's a function that has that property? Define, I don't know. I guess it wouldn't be a bilinear form though, but psi of xy equals the absolute value of x minus y, right? That'd be an example of something that satisfies. I'm just taking distance functions. Any metric would satisfy this property. There we go. Further, psi is called positive if and positive definite if unless x equals 0. Okay. We will say that we have endowed the vector space V with an inner product once we have selected a positive, definite, symmetric, bilinear form. Cool. Because the inner product is selected once and fixed for all time, we will denote the inner product by, boom, just like that. So you basically have to have a positive, definite, symmetric, bilinear form. Wow. Cool. And then here we have some proofs and stuff. There's more content up here, but you can see it's pretty hardcore, right? It's not, solve for x, super easy, or it's not even like, oh, here's a hard word problem. No, it's beyond that. It's pretty hardcore. So you need to have some. I would say you definitely want to know how to write proofs before you jump into this, and you want to have some analysis probably, and some algebra. Just a couple of hardcore math classes. And then you can jump into something like differential geometry. I'll look for this book, and if I can find any copies, I will leave a link in the description in case you want to check it out. And if you want to learn math, I have courses. They're on Udemy, but check them out through my website, mathsorcerer.com. And also, if you found any value in this content, feel free to hit subscribe. Key takeaway is this is a classic book on differential geometry. It's very hardcore. It's a nice book. Take care.